In this video, we explore what agglomeration economies can mean for city size. If the agglomeration economies just cause demand to slope down a little less, then everything's normal. Demand slopes down, supply slopes up, and there is a single crossing point that determines housing prices and city size. But what if the agglomeration economies are strong enough to make demand slope up? There are lots of ways in which demand can slope up that won't matter. For example, what if willingness to pay for the city is greater than supply costs for the first person? Demand then rises a bit with city size, reflecting the agglomeration economies, but still remaining above the cost of providing housing. And then ultimately, demand starts falling, and then it crosses the supply curve. Things look a little funky, but there's still only one crossing point, and everything more or less works like before. What if willingness to pay starts above supply costs, then rises everywhere? But that upward slope is still less than the upward slope of the supply curve, and eventually the two curves cross once and only once. Again, no big whoop. Supply equals demand in a unique equilibrium, even though demand slopes the wrong way. The key is that it doesn't slope up more than supply slopes up. Okay, let's try something far more radical. Let's assume that the willingness to pay is actually less than the supply curve when no one lives in the city. Basically, nobody wants to be in a place where no one else is. Firms aren't productive on their own, and it is lonely as heck. But then the agglomeration economies set in, and the willingness to pay for the city starts to rise. In this case, we're assuming that productivity in the city is really low when no one else is in the city. But as the population expands, productivity and wages increase rapidly. Eventually, and keep in mind that this is an illustrative example that may or may not reflect the real world, willingness to pay exceeds the cost of supply of housing. But then, eventually, the agglomeration economies flatten out, and the two curves cross again, this time for good, with housing costs, from that point on, above willingness to pay. So, as you can see, supply and demand cross twice. Which of these is the equilibrium? Actually, there are three possible equilibria here. The first equilibrium involves 0 people in the city. When no one is in the city, the cost of construction exceeds the willingness to pay. No one is going to build any housing, and no one wants them to. This is a perfectly reasonable equilibrium outcome that reflects the vast parts of the globe where no one has built a city. Then, there are the two other points, both of which deserve to be called equilibria. But one of them, the lower crossing point, isn't really a stable equilibrium. Imagine, for example, that a few people left the city from that point. Then the willingness to pay would be lower than the cost of housing. Then builders would probably build even less housing, and the city would shrink away. Imagine a few more people coming to the city. Then the willingness to pay would exceed the cost of construction, and the city would grow more. Any deviation builds on itself from that middle point. And in a proper dynamic model, this point would determine the level of size that a city has to reach to keep growing. Once there are agglomeration economies, city size can build on itself, and there may be multiple equilibria. One in which the city doesn't exist or is really small, and the other in which the city is really big. That suggests that the growth of any particular city in any particular spot might just be a matter of chance.